Hey everyone, it's Miss Sullivan, and today we're going to be talking expanding brackets. So this is the third video in your algebra unit. So just a little reminder of how we've been talking about algebra. We've been discussing it as a language. And so it's a language that helps us shift our thinking from the particular to the abstract. So we've talked about like 3 different levels. So just as things can become more or less abstract in art, in maths, things can also become more or less abstract. So on the first level, remember we talked about algebra helping us find like a missing number. It's a pretty basic level. So like 4 people out for dinner, the bill cost $240. So 240 divided by 4 is going to equal, the missing number. That's how much we're each going to pay for dinner. So that's the pretty obvious level. On the second level, remember we talked about algebra as providing us with formula so that we can insert different data, things like distance and time so that we can work out different speeds, and yet the formula stays the same. And then there was the magical third level where we're unlocking the laws of the universe. So just a little reminder, stuff that we've already talked about in terms of unlocking the laws of the universe. This is the stuff we can't escape. It's just how the world works. Anything plus 0 is going to equal itself because you've done nothing to it. Anything times 1 is also going to equal itself. Obviously, when we talk anything, we're not talking 0. So if that number is 2, 2 plus 0 equals 2. 2 times 1 equals 2. If that number is 2 billion, 2 billion plus 0 is still just 2 billion. 2 billion times 1 is 2 billion. Nothing's changed. We also talked about commutative law. So this idea that when I've got a number and I add another number to it, I get a different number. Now it doesn't matter what order I've got these numbers in. When I'm doing addition, it can be A plus B or B plus A, and I'm still going to come up with the same number. Same deal with multiplication. When I multiply one number by another number, I get a completely different number. And it doesn't really matter if I go A times B or B times A, I'm still going to end up with the same number. That's commutative law. And we need to remember that it doesn't work for subtraction or division. It only works for addition and multiplication. We also talked about inverse law, where we had a number and its opposite, and when you add them together, you end up getting 0. So let's just do a quick little example here. 2 plus its opposite, negative 2, basically 2 minus 2, is the same thing as saying minus 2 plus 2. Think about us moving up and down the number line. I can start at 2 and move down 2. Boom, boom. I'm going to end up at 0. I can start 2 below 0 and add 2. Boom, boom, and end back up at 0. Same deal when we're talking about things like multiplying a number by its reciprocal. Remember, its reciprocal, a over 1. Its reciprocal will be 1 over a. So again, let's use the example of 2. So we know that 2 over 1, which is just 2, times 1 over 2, which is a half. So 2 times a half is the same as saying a half times 2. And in both instances, it's the same sum. Thanks to commutative law, we know it doesn't really matter what order we put them in. We end up at 1. So any number times its reciprocal, we end up at 1. Think about it. 3 times 1/3. Yep, I get 1. 1/3 times 3. Yep, I get 1. So here's another one of those laws of the universe. It's distributive law, and it applies to brackets. So every term inside the brackets must be multiplied by the term or the number outside the brackets. So when we're working with brackets, step 1, expand. Step 2, simplify. So let's give this first one a go. If I wanted to work out the area of this shape, I know that I need, it's 3 down here and it's 3 down here. And just pretend I don't know what 6 is. So I know that if I add 4 plus 2 and I times it by 3, I'm going to get the area of this rectangle. So in algebraic terms, that's 3, 4 plus 2. Remember, when we're working in algebra, one of the conventions is to eliminate multiplication signs. So just to avoid confusion, when we'll start with method 1. Let's expand first. So 3 times 4 plus 2. So remembering BIDMAS, this has to stay in its little bracket, so I do it first. So 4 plus 2 is 6. 3 times 6 equals 18. Terrific. If I look at method number 2, again, I'm going to start by expanding before I simplify. So to expand here, I'm going to say 3 times 4 plus 2. And this time, I'm going to use distributive law. So I'm going to say 3 times 4. 3 times 4 is, actually, I'll write the full thing out. 3 times 4 plus 3 times positive 2. Great. Using BIDMAS, I know I've got to do multiplication before addition. So I get 12 plus 6. And I end up at the same place. I expanded and then I simplified. Now I can work out what's in the brackets when I know the numbers. When the numbers are constant, I can work out what they are. But when I'm working with pronumerals and variables, I don't know what they are. Sometimes, remember, I'm not going to arrive at a nice, neat number. I'm just going to be able to clarify the situation by simplifying the expression. In this case, I could come up with a number because I had actual numbers. So I had constants up here, my 4 and my 2. But if that was A and B, I have to use method 2. So, as we saw when I emphasized 3 times positive 2, you need to watch your signs. Let's give ourselves one little quick reminder. Adding a negative or minusing a positive, moving to the left down the number line. I'm either increasing a debt or decreasing an asset. When I'm multiplying or dividing, different signs, I end up with a negative. When I'm working with the same signs, increasing an asset or decreasing a debt, adding, I'm moving up the line. So subtracting a debt or adding an asset, I'm moving up the number line. And when I multiply or divide, when the signs are the same, the answer's positive. Excellent. Another quick little thing that we're just going to remember, just remind ourselves of, we're going to remind ourselves about invisible ones. So remember when we see an X, this is super important when we're expanding and when we're simplifying. When we see X, it might not be helpful to just look at it as X. Let's get a little bit of light off that for a second. That's a bit better. Sometimes it's not helpful to just look at that as X. Sometimes in order to work with it, we need to remember that it might be X over 1 might be a better expression, or X to the power of 1, or 1 times X. That might make it a little bit easier to work with. When we're looking at brackets, let's remember that X plus Y, really what we're saying there is 1 times X plus Y. That's very important because if I were to change that to a negative on the outside of those brackets, and I remember that I'm multiplying by -1, -1 times X, the signs are different, so the answer's negative. -1 times Y, the signs are different, so the answer's negative. Very different to 1 times X is X, 1 times Y is Y. Positive, 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 positive. Really different outcome. Similarly, if I change this to X minus Y, and there's a minus sign out the front, a negative and a positive comes to a negative, but a negative and a negative, positive Y. Just stuff that we need to keep in mind while we're working on expanding and then simplifying. One last little thing I want to remind you about is collecting like terms. So remember when we're doing addition and subtraction. Again, watching our signs, but when we're doing addition and subtraction, we're looking for like terms. In this instance, I've got 4x squared. That is not the same term. X squared and x, not the same. But that is. So I take my positive plus 2x squared minus 3x. Great, I've taken this whole thing down. Minus 7x. So just noticing there that I've accounted for every single sign. So 4x squared plus 2x squared is 6x squared. Negative 3 minus 7. So I'm decreasing an asset. I'm moving this way down the number line. Negative 10x. So that's the idea of grouping like terms. These guys are like terms, and those guys are like terms. And I took into account all of the available symbols, knowing that that's an implied positive. Excellent. Little reminder that this algebraic expression, it doesn't become an equation until I add an equivalent sign. Okay, so let's move on to a couple of examples. So basically, here's our rule. We looked at it up here a little bit. Let's just do it again. Oh, let's just make sure we can see that. That'd be handy. All right, well, we'll focus on it now. Every term inside the brackets must be multiplied by the term or number outside the brackets. Well, here's a term. So let's simplify this. We've got A times B plus A times C. Excellent. This time I just eliminated it straight off. I can't simplify that any further. Let's have a look at this one. We'll expand this one. Negative A times positive B. So let's just write in negative A times B. Okay, plus. Now we've got a negative A times C. Negative A times C. So let's have a look here. The signs are different. Let's look at this one first. So the answer's negative. Negative AB. The signs are different, so the answer's going to be negative. And I know that when I add a negative, it's the same as just saying minus AC. Excellent. Let's have a little look here. Again, remembering to watch our signs. That's the whole point of this. So, looking at this one, we've got x times x is x squared. X times plus 4 plus 4x. Positive 5 times x plus 5x. Positive 5 times positive 6 plus 30. Can I simplify? I sure can. These guys are like terms. Positive 4 plus 5 comes to 9x. So this equals x squared plus 9x plus 30. Terrific. A little reminder again, these are like terms, and that one there, this number that doesn't change, notice it's the same here, it's the same here, that's called our, just a little reminder that it's a constant. These are variables because we don't know what they are. That's a constant. All right, just as a little checking our signs, let's do this one. X times x, x squared. Positive x times negative 4. Signs are different, so the answer's negative 4x. Negative 5 times x. The signs are different, so the answer's negative. Negative 5 times positive 6. The signs are different, so the answer's negative. Again, with the like terms, again, we remember that's called a constant. So we can simplify this to x squared minus 4 minus 5. We're moving this way down the number line, takes us to, because we're decreasing an asset, takes us to 9x minus 30. First we expanded and then we simplified. Terrific. All right, finally, just a little reminder, again here, Just a little reminder about our invisible. 1. So, first we need to expand. We're going to say 2x minus, so the signs are different, so the answer is negative. Negative 1 times 3x is negative 3x. Negative 1 times positive 5, the signs are different, so the answer's negative. Oh look, we've got little like terms here. So 2x minus 3x takes me to negative x, I know there's a little invisible 1 there, minus 5. Terrific. That's equivalent to that. That's a simplification. Having a little look over here again, just as another practice example, where I've got a number outside 2 brackets. Let's look here. 3x plus 3 times 5, 15, negative 2x, a negative and a negative. The signs are the same, so the answer is 2 times 1 is negative 2, times negative 1 is positive 2. So, any like terms? Absolutely. I've got 15 and 2, which comes to 17. And here I've got 3x minus 2x. Just comes to x plus 17. So 3x take away 2x came to 1x. 15 plus 2 came to 17. Excellent. Hope that's helpful.